Hey guys, it's Miss Bishop, somewhat semi-live and in person. I'm sorry that I can't be at school today. I've got that training that I talked to you guys about, so I am doing a video for you so that we can continue on with our lessons without wasting any time. So, again, sorry I can't be there to teach this to you in person, but I'm hoping that this video will work well for you because you have the opportunity to rewind if you need to rehear something. So, let's go ahead and get started. So we are moving on in our lessons about inequalities. Remember, this is part 2 of our unit 4, which our unit 4 is about equations and inequalities. So we already did equations, we're done with that, and now we're moving into inequalities. So yesterday we talked about one-step inequalities, and we talked about how solving a one-step inequality is the exact same way that we would solve a one-step equation. And the same goes for two-step inequalities. So we're doing two-step inequalities today. And the same process, we use the same process to solve two-step inequalities. So, how do we solve it? We're going to treat the inequality sign like it's an equal sign, and we'll solve for x by isolating the variable like we always do. Get your variable by itself. Then we'll use inverse operations. Please remember that inverse means what? Opposite. Very good. So we'll use inverse operations to solve, and then what we do to one side, we have to do to the other. Have to. You don't have that option because the whole point is to keep it balanced. So let's start with this first example here. So again, we're just going to kind of ignore this inequality sign for now, and we're just going to think of it as an equal sign. So if that said 2x plus 4 equals 24, what would our first step be? Well, we want to isolate our term with our variable. So I'm going to circle my 2x, which means plus 4 is in my way. Well, how do I get rid of plus 4? I have to do the opposite, which means I'm going to minus 4. So I'm going to minus 4 from both sides. 24 minus 4 gives me 20. And then I'm left with 2x because 4 minus 4 is 0. So now I have 2x. Again, I'm going to draw the inequality sign, but we're just kind of ignoring that for right now. Here is a basic one-step equation problem or a one-step inequality problem. Super easy. I have x times 2, and the opposite of multiplying by 2 is dividing by 2. Very good. So then I should be left with x is greater than or equal to 20 divided by 2 is 10. So your final answer is x is greater than or equal to 10. So I haven't done anything with my inequality symbol, which is why I say that it's okay for us to just kind of ignore it for a minute, because it doesn't do anything or it doesn't mean anything or change anything in our process of solving the inequalities. But it does change how we graph the inequality. So down here, we have some arrows and we have a dot. Now I can move my arrows and my dots. You cannot because they're on paper. So you're just going to draw your dots accordingly. So remember, we're now focused on our inequality sign, and we're looking at what does it actually say. Sorry, I wanted green. What does that actually say? Well, that says greater than or equal to. Well, if I have greater than or equal to, that or equal to means what kind of circle am I supposed to have? All right, I'm supposed to have a closed circle because remember that or equal to includes it, and that closed circle means, hey, I'm including this number. So let's go ahead and number our number line. So I'm just going to put 10 right here. I'll put 11, 12, 9, and 8. You can go ahead and finish labeling your number line. I'm going to keep it simple. So like we just said, greater than or equal to means I'm including 10 because 10 can be equal to 10, so it's a closed dot. And if it's greater than, what direction am I going in, left or right? I'm going to go in the right direction. So that's what our graph should look like. We should have a closed circle because we're including 10 in the solution set. Remember, inequalities have many, many solutions because think about what is greater than 10. 12 is greater than 10. 15, 25, 150. But it also has that or equal to, which means that 10 is greater than or equal to 10. So we want to include that. All right, our next example, Remember, we can solve these a couple of different ways because it's distributive property. I'm going to go ahead and actually distribute this just to get it all on one simple line and to get rid of these parentheses because this parentheses can be confusing. So I'm going to multiply 3 times p, which is just 3p, plus 3 times 1, which is 3. Now I have 3p plus 3 is less than or equal to 18, and from here I can solve it. So again, we want to get our term with our variable isolated. We want to get it by itself, so plus 3 is in my way, and the opposite of plus 3 is minus 3. But do I do it just to one side? No, I have to do it to both sides because I want to maintain that balance. So 3 minus 3 cancels out. 18 minus 3 is 15. So now I should be left over with 3p is less than or equal to 15. From there, again, trying to get p by itself. So I have p times 3 right now. The opposite of times 3 is dividing by 3. 3 divided by 3 cancels out, and then 15 divided by 3 is 5. So you're left with p is less than or equal to 5. That's your final answer. P is less than or equal to 5. So again, going to our graph, we want to label our graph. So in the middle, I'm going to put 5, then 6, 7, and below it, I'll put 4 and 3. And I just put 5 in the middle just because that's easy. What I know what the answer or what I'm comparing it to should be, I just put it in the middle usually. You can start with 0 if that's what you want to do. I just, for ease sake, put 5 in the middle. All right, so again, looking at our symbol less than or equal to, what does that mean? What kind of circle am I going to have? A closed circle. Very good job, because again, the or equal to is what tells us it should be a closed circle because we're including 5. If I have that open circle, that means 5 is not an answer, which 5 would be an answer here. And then I have less than or equal to. So which direction does less than go in? Less than goes in the left direction. Awesome, very good. So that's how our graph should look. We should have a closed circle shading into the left-hand direction. All right. Here's where things start getting a little tricky and a little fun. Division's always fun. So again, we're trying to get the term with our variable by itself, which is m divided by negative 3. So minus 3 is in my way right now, so I'm going to add 3 to both sides. And here's where negatives come into play. So negative 3 plus 3 cancels out, and you're left with m divided by negative 3 is less than negative 6 plus 3. My signs are different. I have a negative and a positive, which means that my answer is going to be a negative answer because 6 is bigger. So I'm subtracting 6 minus 3 is 3, and 6 is bigger, which means it's a negative 3. So I have m divided by negative 3 is less than negative 3. Lots of 3's. All right. So now again, this time I can get m all by itself. I'm dividing by negative 3, which means I want to multiply by negative 3. All right, so here's where it's tricky. Remember, we talked about this yesterday, that anytime we are dividing or multiplying both sides by a negative number, what has to happen? Our sign has to flip. Anytime we're multiplying or dividing both sides by a negative number, our sign has to flip. So it's no longer going to be less than, but it's going to be greater than. And we're just going to automatically do that so we don't forget. So negative 3 times negative 3 cancels out. So I'm left with m is greater than negative 3 times negative 3. 2 negatives make a positive 9. So m is greater than positive 9 is my answer. So looking at our graph, let's go ahead and label it. I'm going to put 9 in the middle, 10 and 11 on the side, and then 8 and 7 below. So now I have m is greater than 9. Okay, greater than. What kind of circle does that tell me I'm going to have? I'm going to have an